Hi all, welcome back to my YouTube channel. Topic that we will have a look at today is binomial trees from paper 4, that is valuation and risk. So I'll just cover up the some part of that chapter, binomial trees. Before we go ahead, I request you to subscribe to my channel, share with your friends so that they also get benefited out of it. Believe me, there is a lot of efforts behind coming up with videos like this. So please do share with them as well and subscribe to my channel. So let's have a look. See, first of all, I'll just so we'll look for what it is used. So by, as name says that it's a binomial. So there are let me just so there are two nodes to at each step. There are two nodes. So if you see from this particular what it is in finance, we will see the application in finance. So I'll explain you what it is. But there are two nodes at each step. That's why the name is binomial. Over where we will see the application in the finance. So basically we'll derive the option price by assuming, I mean, by calculating that what are the two possible outcomes from the stock price from its current value. Say, for example, if I term the current stock price as as 0, and we will calculate what what's the expected stock price at year one, and what is the other value. So we'll assume that it will either go up or either go down. There are no interim values, so that's why it's a binomial model. So we'll calculate, say for example, if I call this as year one and this as year two. So if assuming assume if this is a European call option, and I had to, and which expires in 2 year, and if I were to value this call option today, what's its value? And currently what I am covering is mainly for European. For American, the trick will slightly vary. So just make a note of it. Currently, we'll be looking at European option. So method I'll be telling you is strictly for European option. So let's have a look. So we need to understand few parameters, and then again I have jotted down the steps. The how do we calculate the price? We'll see one numerical by applying these steps. So the U basically indicates that it's a size of up move, and we calculate using it e to the power sigma root t. So as you know that E is a constant. Sigma root t is like what's the standard deviation for that particular term. So sigma is annualized volatility, and t is the length of each node. So if I were to give you an example, what exactly tells you. So if your stock price is 100, then basically what you will tell you by how much percentage your price will go up in the next year. So if it is 10%, then 10% of this is 10, and next year your price is expected to be 10. And if your D, say for example, is again just for sake of understanding, it's again a 10%. So it will tell you by how much percentage it will come down in the year one. So it would be 90. So these are the U and D, and how these are calculated. We have been given the formula. It's e to the power sigma root t, and D is just do the reciprocal of U, then you will get a down D. It's a factor by which your stock price will move up or down in that time window. And sigma, as we said, it's annual volatility of underlying asset returns. Very important. Do you see, basically, when we learn the finance, we tend to miss important aspects like we tend to think that sigma is will be a volatility of stock price. So no, it's for returns. And believe me, these are the basic questions you are asked in the interview. they'll just ask you what's the sigma in BSM, black scholes or binomial model. So it's a volatility of the returns and not really the prices. So key point for an interview also. Let me mention over here. Key point. So just extract and the probability of this up move and down move is calculated by this term. So point to note over here is when you are calculating the probability over it's e to the power RT. There is a lot of science behind when you actually use this formula. There is a lot of work, research that was done already. We are just the end users. So for us, it's just important to know that when you calculate the factor, it's e to the power sigma root t. And when you're calculating the probability, it's e to the power RT. E to the power RT minus d and u minus d. And probability of down move would be 1 minus pi u. Basically, what it's saying is, if I go back to my earlier example, what would be the probability of stock price going to 110? And this particular node would give me the probability of stock price going to 90. So it's a corresponding probabilities. What is the chance that your stock price would go to 110 and what is the chance that your stock price would go to 90? So these are the probabilities that we would need when we'll use the binomial model to value the option. So these are the formulas, and the R is a continuously compounded risk-free rate, important points. Okay. And these are the steps I have jotted it down. I mean, these will be very useful when you will be appearing for the exam next month or even in later if you are doing some further studies. This will help you a lot. So just to summarize, calculate UND using this formula, e to the power sigma root t. Calculate pi u and pi d. These are the probabilities of the nodes corresponding to these. So first of all, calculate the factors by which your stock price will go till these nodes. Then calculate these probabilities. And once you have this factors, calculate the spot price at say for example 10% up till here. Again, it will move 10% up to the next node. So calculate all the stock prices at each nodes, and then calculate the call price at each node. So what I mean, so as you are aware that value of call is max of 0 spot minus strike. So at each node, because you have the spot, strike you will be given. Calculate the call price at each node, discount back to the 0. That's your the value of the call option. So let's have a look at the one of the numerical. So this is a numerical that we will do. Let me go back to red to highlight some key information. So the current price of ABC impulsive is $20. Let me write it over here. So spot price is $20. The annual standard deviation is 14%. Annual standard deviation of the stock returns is 14%. And so no dividends. So maybe the case that we are looking at is with no dividends. There is a slight tweak in the formulas, but just for basic understanding, I have kept it for no dividends. Using this information, calculate the value of your 2-year call option. Let me have a look at a original question because I think some information is missing. Yeah, say for example, your strike is $20 only. So at the so currently you are in so there is no profit, no loss when you are currently standing at 0. Now we have been asked to calculate 2-year call option. So we have to calculate C at 2 years using this information. And so there are 2. So this is year 1. So if I were to tell you, this is year 1 and this is year 2. So your time interval is your 1 year. So total T is your 2, and what you have been given over here is it's yeah. So we'll calculate as we said, we'll follow the 6 step and calculate the price of call option. So if I were to calculate U, let me again go back to black so that yeah. So what you have to calculate U is your e to the power sigma root T. Okay. So your U will be e to the power 0.14 to root T. Okay. So just make a note of it. T is your length of the steps. Okay. It's not really the complete step. It's when you say 2 years, length of each step is 1 year. So we'll take T as 1. So let's calculate this and see how much it comes to. Give me a moment. So your U will come to just a moment. My calci has stopped working. Yeah, your U will come to around 1.15. So it's 1.15. If I do reciprocal of this, so your D is 1 by U. That is 1 upon 1.15. That would come around 0.87. It means that if your stock price is, let me again switch back to red to just for your letter reference. So currently as we see that our stock price is $20. Now what will happen at SU, if I had to calculate SU, this would be equal to 20 into 1.15, and over here it would be 20 into 0.87. Whatever these numbers will come, we'll calculate. And again, if I were to calculate this, it would be 20 into 1.15 into 1.15. We'll see what this number comes to. And this stock price would be, so over here it's a down node. So the factor of down node was 0.87. So it would be 20 into 1.15 into 0.87. Similarly, when I'm coming down from here, it's 20 into 0.7, again 20 into 1.15. So either ways, if you come from here to here, or if you come from here to here, it's just a order that will change, because over here you are coming first down. So the probability of down is 0.87, and then you're coming up from here. So it is a factor, and over here it would be 20 into 0.87, 0.87. So let's calculate these numbers. So how much these are coming? So you're 20 into 1.15, it would be approximately 23, and over here it would be 17.39, and it's approximately 26.46. And over here, I mean, because if you see that U and D were reciprocal of each other, so 1.15 and 0.87 will get cancelled. Again, you will come back to 20 over here, and it would be around 15.12. Now we have the stock price at all the nodes. Now what we'll do, we'll calculate the probability of upper mode and lower mode. So we'll see that probability of U is equal to e to the power RT minus D and U minus D. So if I were to write it in the question form, it's R we have been given is 4%. It's here. So 4% into T is 1 minus your D is 0.87, and in the denominator it's 1.15 minus 0.87, which will come around to, give me a moment, it would come around to 61% approximately. Just give me a moment. So it would be 61%. So probability of move is 61%, and probability of down move would be around, say, for example, 61. It would be 39%. It's 1 minus up move. So just I'll summarize whatever we have calculated so far. So your U was 1.15, which where we calculate over here. Your D was 87. These are the factors why your stock price will move, and probability of reaching this value and this value. So let me write first U. We got it around 61%, and probability of D is around 39%. This is a key information that we have calculated so far. And based on these factors, we have calculated the stock price at each node. So let me box the stock prices. These are the expected stock prices at year 1 and year 2. And probability of having these stock prices is, say for example, stock price going to 23 in a year 1 is 61%, and the stock price going to 0.87 is just give me a moment, let's say 39%. Similarly, when you calculate over here, it's 61%, and over here it's 39%. Likewise, upper node 61%, lower node 39%. Now what we'll do, we'll just calculate the call prices, last step. So calculate the call price at first calculate the call price at both nodes of year 2, and then at year 0, and at year 1 and year 0. So over here, like as we know, the strike is $20. What will happen that at this node, if I apply the same formula which I gave you over here, payoff call payoff formula. So if I subtract the strike price, my call value would be, let me write in a different colors so that at least you can spot the information later when you will refer the video. Right, and say blue. So for example, call price would be your spot minus spot is 26.46, and strike is 20. So your call price would be 6.46. And over here it's spot, your spot is 20, and your strike is also 20. So call is not expired. Similarly, over here the spot price is less than your strike, then again it would be 0. Oh, and similarly, over here, the value of the call option is 3, 20 minus 3, but I'll tell you why this will. So it's a key information. Over here, you will not calculate the call value because it is a European option. You cannot exercise it in between. So you can just exercise it at the maturity. So this step is done only in the American option. So what we'll do, we'll just calculate the expected value of this. So over here it's 0. So the call price is 6.46 and the probability of having this call price is 61%. Okay. So what you will do, your expected value and the call price into expected value. So your 6.46 into the chance of getting this value after 2 years is 61%. So when you discount it from second year till first year, so let's calculate directly till 0 because there is no chance that you will expire, you can exercise it in year 1. So what you can do is you can just directly calculate what is the chance of getting this call price and discounted value of this. So this node is achieved by going one upper node. The probability of that is 61%, and again 61%, and 6.46. Over here, there are no expected values, so we will not consider this. So your call option price would be 6.46 into 0.61 into 0.61 divided by e to the power 0.04 into 2. We are discounting it at a rate of 4% from back to the 0 from 2 years. So value of this would be approximately equal to, just a moment. So it would come around 2.4 in the numerator. So so it's 2.4 divided by 0.0 to the power 4 into 2. It will come around to $2.21. So call price today with these detail is $2.21. Similarly, in frmexam, you can be asked to calculate the price of the put option from this information. You can use the put call parity and calculate the price of put option as well. Hope you like the videos. Please do like and comment if you really like the videos. And just the exercise for you. You can do the same exercise for American option and comment in the put the answer in the comment box and I'll verify it if that's correct. Thank you very much. Stay connected.